Ladies and gentlemen, welcome to Introduction to Programming Part 3. In this session we will look into functions. Defining your own function is very useful if the code becomes more complex. Functions allow you to combine logical parts into a separate entity of your code. In the following we use a variant of your last example, where we have the nested loops, to put a part of the code that creates the random surface and wrap it into a separate part in a function which we can call from our nested loop. Therefore, let's look into Rhino Grasshopper how to do this. Please open our basic concepts file and right-click on the example number 5 and enable it. After enabling it, you should see these the grid of rectangles, the grid of squares. By the way, it could be that your Rhino window is somewhere zoomed out or the pen has moved your object away. In this case, you can activate your component, right-click on it, and so right-click on the canvas and press the zoom command, and then it zooms in the content of the selected component or the output of the selected component. Okay, open the script window, and here we don't see a lot of new things, but it looks different, and that's exactly what our functions do. We have the nested for loop, that's what you already know. Two for loops with our iterator variable. The first is the I and the second is the K. For our list, we just changed our data type that we store in the list to extrusion objects instead of BREP surfaces. And that's just a little extension to show you a different data type, by the way. But the most important part for this lesson is this line of code. Create random extrusion, parentheses, containing I and K, so two variables. And this returns something that we assign to a variable that we call myExtrudedObject, which you find here is an extrusion object that we put afterwards in our collection of our extrusion objects. You remember we have done something very similar with our rectangles before, but we have had a lot of code in here. All this code we took out of this inner loop and wrap it into this function. So now we enter the second part after this gray area here in our script window, and we add here some new parts. So the private extrusion, create random extrusion. This is the name of our function, create random extrusion. So this is a name that I have given to this function. You can give it a completely different name. So create random extrusion different is also working, but you have to call it in this way. So if we press play, it still is doing the same thing. But if we have a different name, and you see nothing is happening, and our error, our panel gives us an error which says the name create random extrusion is isn't existing in the current context, and it gives you the line 80 as the place where the error occurred. That's very helpful because we can look up at line 80. Here we do something that is not existing because the name of our function is different. It's now it's the same. So You can give it any kind of name, but it needs to be consistent, of course. So it's your own kind of function that you create here. Okay, that's obvious that you have used the same syntax also. The capital letters need to be the same. This one wouldn't work as well, so your compiler differentiates between capital letters as well. You see, in the parentheses we define, or we read, two input variables I and k, which have the same name as the variables that I sent, but I could also give them different names. That's just for you, not to confuse you, and therefore I use the same ones, but I could also give this an arbitrary name that I would use in my function, and my function goes from the curly bracket where it opens until where it closes. In this area, these variables are valid by their names. Okay, and this part of the function tells me what object I will return after I executed my function. So in the end of the function, I will return an extrusion object. Good. Inside the function, there is nothing new. That's what you already know. We create our rectangles, our squares in this case. We use the max random value. And we use the I and k iterator variables to control our coordinates. We create a rectangle with the plane, and here there is something new that I put in here, the transform command, where we can rotate our objects. And here is something that we will see later, and we can also change the type of the object with an if condition, but this will be part of the next lesson. Therefore, in this example, we don't need it. Here the NURBS curve. This will need. Okay. The rotation. This is the transform command, which you can find in the namespace. Again, you remember in the Rhino Common API, you find the transform methods in the transform structure. And if you look into the methods of this structure, there you find different ways to transform objects. In this case, we will use a rotation transformation, and we can look into it. So it tells us that it needs two parameters, a double value, the angle in radians, and the rotation center around which I want to rotate my object. Okay, and that's now what I want to do. I use my rectangle. It has a transform method, and the transform method of my rectangle needs this transformation structure that we've just looked up in the Rhino Common API. Here you see this is the rotation value. It's 0 at the moment. I want to change it to 0.3, which is the degree value, and I use the center point of my rectangle to rotate around it. Good. Later on we will change this by degrees, because it's easier to remember rotation in degrees. Therefore we will call another function. But first of all, let's continue with this function. So we said we want to return an extrusion object after we executed our function. So now we rotated the object. Finally we transform our object to a NURBS curve, and what I want to do is I want to extrude my NURBS curve. Here you find another extrusion object. This is again from rhino.geometry. That's why I've written it in front of the extrusion, but we could also delete it. This is only for you to remember you from where these objects come from. And in this case, the extrusion is not created with a new keyword, but with the command of the extrusion dot create, and it expects 3 parameters. You can look up what parameters you can send to the create method. In this case, it's only 1. Sometimes you have more options. So it needs the curve that shall be extruded, the extrusion height, and a Boolean value which tells the command if there should be a cap on top and on the bottom of your extruded object, of your extruded shape. Otherwise it would be a kind of a pipe with open ends. In this case it's closed, so it looks like a volume. And then we return the my extrusion object. So this return keyword sends the extrusion object that you just created to the output of your function. Now let's go back where we've called the function. So here we called the function, send the variables to this function, and in the end we send back the extrusion object and store it in this variable, which is used to store it in a list, because we create many of these objects for our grid, stored in a list. And finally we return the list, and that's the end of our code. As mentioned, there is another function, so we can also call a function from inside the function. That's what we want to do now. I added you here at the bottom another function that is doing something very simple. It just converts degrees to radians. So the definition of an angle in degrees is converted to the radians by this formula. What we do is we send the degrees to the function, and then we have this mathematical formula, and we return the result, which is the value in radians, as a double value to the outcome of the function. Good. We can use this here. For example, we say we want to have the rotation in radians. This is, I want to call my function, and let's say 45 degrees shall be converted into radians. And since this transform rotation only accepts radians, I need to send the converted degrees now in radians to the function, and if I run it now, it's converted by 45 degrees. Very nice. Now what we can do as well is we can read an input variable, which I prepared here already. That's the number of rows and columns that I use in my grid of objects that I create. What I want to do is I want to add another input variable for my component. I can add here one with the plus, and I can change its name to, for example, rotation. So that's again the name of a variable, and that you can choose any kind of name, but you shouldn't use a name that corresponds to an already given or assigned keyword, which is usually marked in blue in the script window. And I want to say that I send an integer value as input data type that I call rotation. I need to close this window. Only if I open it again, my new input variable is visible in my script window. So I have an integer value rotation. And now I want to send this rotation, the value that I put into it, to this place. So I can only read it in the run script part of my code, but now I want to send it to my custom function, to my own function. Therefore, what I need to do, somehow I need to send it to my function. But if I run it now, I will get an error because my function doesn't have an input with 3 arguments. So here the message is there is no overloading for my method create random extrusion, which accepts 3 arguments. What does overloading means? This means you can create the same function twice. So I can just copy and paste it. And so in this case it wouldn't work because I cannot have the same function with the same number of inputs, but I can create this same function with 3 input variables. And this is now an overloading, or my function is now overloaded because I can have it either with 2 input variables or with 3. And now I can take this rotate. So now you see I changed rotation, the variable that I read here, to another name because this doesn't need to be the same name. I can change it. Now it's rotate without me, and I use it here instead of 45. I use this input variable. Now I send my variable from here to this function. This one is not executed at all. And now I rotate my rectangles by my input variable. Now let's do this. Therefore I need a value if I want to create it. So you can create a slider variable by, for example, 40 and wire it to your input variable. And what you see, it works very well. I can I can change the value of my input variable, and it is sent automatically to my function and creates my objects and returns the objects and sends it to the output. So wonderful working own function. But in my case, I don't need an overload of my function. I can simplify this, so it's not very good to have 2 times the same function with the same content. It's difficult to maintain. If you want to change something here, then you have to change it there as well. So what we can do is we can delete this function again and define our input variable. This time we call it only rot, and give it a value. So if we assign a value to our variable, it doesn't, you don't need to specify it here. So you can do it as we do it now. So if we run it, it should work. Let's close the window and test if it's still working. So you see, it's a bit green. You see our rectangles are still rotating, even if we've deleted our second function. Now we have only this function that accepts 3 variables, and we have 3 variables here. But the nice thing is we can also call our function as we have done it in the beginning without any parameter, and then it would use the value that we assigned here equals to 0. So no rotation at all. And our nice slider wouldn't do anything. So if I change here my values, no effect, because I don't send the value to my function, of course. Right? Just a hint, you can do these kind of assignments, so to assign a value to a parameter only from the right side to the left side. Means you cannot say you set k to 0 and don't have an assignment here. This wouldn't work. So if I run my code now, I receive an error message. That's not allowed. We need one here as well. So we could have something like this. This works. So now we've changed this as well to an initial value, which is overwritten by this one. But it's not allowed to do this only to the left or in the middle, only from the right to the left. Well, now you know already the basics of creating your own functions. You know how to overload them. You know how to define or predefine a parameter value and change or be flexible with the number of variables that you send to your function. You know how to return a function, and you know how to call a function from inside a function. That's all you need to know for the beginning. Please use this example, work with it, understand it by manipulating some parts, change the names of the variables, try what happens if you change this name, where do you need to change the name inside the function. Really experiment with the values, play around with this code and make your own exercise with it, which shall be something creative coming from you, your own ideas, that is reflected by the possibilities of this basic script. Enjoy playing around with the code.